And we're back in Better Than Ever, still in Chapter 10, 10-3, where we're at this point trying to determine an empirical formula. And so we're looking at example number 5 here. It says to determine the empirical formula of a compound that is 25.9% nitrogen and 74.1% oxygen. And of course that is by mass. These percent compositions are percentages by mass. We learned that at the beginning of 10-3. Now the key here is realizing that again an empirical formula is a mole ratio. It's the lowest whole number mole ratio, but it is a mole ratio. And so what we need to do is we need to take the information that's given to us and turn it into moles and then simply take the ratio. And so if we have a substance that is 25.9% nitrogen and it is 74.1% oxygen, it doesn't matter what size sample that we use, it will always be those percentages. So to make life easier on us, we're going to assume that we have a 100-gram sample. If you have a 100-gram sample, 25.9% of that will simply be 25.9 grams of nitrogen. And 74.1% of that 100 is simply 74.1 grams of oxygen. Now you don't have to pick a 100-gram sample, but it makes the math very, very easy to look at. Alright, so now we know in a 100-gram sample what the masses of the nitrogen and the oxygen will be. Now again, the empirical formula is a mole ratio. So now just change the grams into moles. How do we do that? Well, look at the molar roadmap that's on the back of your periodic table, or it could be up on the board. And you'll know that in order to go from grams to mole, you use the molar mass. 1 mole of nitrogen has a mass of 14.01 grams of nitrogen. Now again, why did I know I'm going to put the grams on the bottom and the moles on top? Because I'm already in grams of nitrogen and it has to cancel out top and bottom. So now you take your 25.9 times 1 divided by 14.01, and I'm getting 1.8487 moles of nitrogen in that sample. We're going to do the same thing with oxygen now. We're going to divide by the molar mass, 1 mole of oxygen over 16.00 grams of oxygen. The grams of oxygen will divide out, top and bottom. And now simply do the calculations. 74.1 divided by 16 is going to give us 4.6312 moles of oxygen. Okay? So now that you have the number of moles of both elements, now you have to get it into the lowest whole number mole ratio. So again, this is the lowest whole number mole ratio. So what we're going to do is we're going to divide through by the lowest one. So we divide through by 1.8487. Divide through by 1.8487. Of course, anything divided by itself is 1. And when you perform that calculation, you actually get 2.5. So this is in a 1 to 2.5 ratio. However, it has to be in a whole number ratio. We cannot have this half here. That's the problem. So in order to get rid of that half, what we're going to do is we're going to multiply both of these by 2. And we really get a 2 to 5 ratio. So for every 2 moles of nitrogen, we're going to have 5 moles of oxygen. So the empirical formula will be N2O5. Alright? Let's try another one. Example number 6. Determine the empirical formula for a compound that is 94.1% oxygen and 5.9% hydrogen. To tackle this, we're going to take the same approach. If you have 94.1% oxygen and 5.9% hydrogen, again, assume that you have a 100-gram sample, which means that you will have 94.1 grams of oxygen and you'll have 5.9 grams of hydrogen. Now again, why can you pick a 100-gram sample? Because you can pick any type of a sample that you want. It's just that this gives you the easiest calculation from the mass percent to the number of grams. And so we're going to follow the same procedure. We want to change the grams into moles because this is a mole ratio situation. The empirical formula is the lowest whole number mole ratio. So 1 mole of oxygen has a mass of 16 grams. And so when you take 94.1 divided by 16, I get 5.88125 moles of oxygen. We're going to do the same thing with the hydrogen. We're going to divide by the molar mass, which means 1 mole over 1.008 grams of hydrogen. Of course, the grams divide out. You're left with moles of hydrogen. So 5.9 divided by 1.008, I'm getting 5.85 moles of hydrogen. And you can almost see already this is basically a 1-to-1 ratio. If we divide through by the lowest one, 5.85, divide this by 5.85, we are in fact going to get a 1, and it's going to be about a 1, but let's go ahead and do the calculation just so you can see that it's not going to be perfect. I'm getting 1.005. which for our purposes is effectively 1. So this is in a 1-to-1 ratio, so the empirical formula would be OH. OH, or you could write it as HO, either way. Alright? So again, the strategy is always going to be to simply change whatever's given to you, and change whatever's given to you into moles, and then change it into a mole ratio. Okay? In the next podcast, we'll go ahead and tackle the next few samples on empirical formulas.